Welcome. Today we are going to talk about combinations. Now, last time we talked about permutations, and permutations were groups of objects where the order of the individual objects matter. A combination is a selection of our objects from a group of n objects where order is not important. So we looked at the number of that there's 6 permutations of A, B, and C. There's just one combination because we don't care whether A comes first or C comes first. We don't care how the A, the B, and the C are ordered. We just care that we have all 3 of them. Okay, so the formula for combination starts off with our formula for permutation, so n factorial over n minus r factorial, but we're going to divide also by a factor of r factorial because that counts the number of ways the objects themselves can be ordered, and since we don't distinguish between, say, ABC and BAC, we need to divide out by that number of arrangements. So let's look. We're going to look at some combinations within a standard deck of cards, but let's talk about it. It's important that you understand a little bit about a standard deck of 52 cards. Some of you have grown up playing cards, some of you haven't. So if you know all this, just bear with us. So there's 52 cards total. Okay, and there are 4 suits. There's spades, hearts, diamonds, and clubs. Spades and clubs are considered black cards, and hearts and diamonds are considered red cards. Within each suit, there's 13 different types of cards. They're often called kinds. So there's ace, 2, 3, 4, 5, 6, 7, 8, 9, and 10s. There's jacks, queens, and kings. The jacks, queens, and kings together form what are called the face cards. Okay, so if the order in which the cards are dealt is not important, so we don't care which comes first, second, or third, how many different 5-card hands are possible? So this is a combination because we don't care what order the individual cards occurred in. And how many 5-card hands are all 5 cards of the same color? So how many are either all aces and all hearts and diamonds, and how many are all spades and clubs? Okay, so the number of ways to choose 5 cards from a deck of 52 cards is 52 factorial over 52 minus 5 factorial, so 47 factorial times 5 factorial. Now, if you are in a position where you're not using your CAS or you forget where you can find the combinations key in your CAS, one way you can do this, 52 factorial means 52 times 51 times 50 times 49 times 48 times 47, on and on and on, 46 times 45 times 44. Well, you're going to stop writing there because look, on the bottom you have 47 factorial. Expanded out, those are all going to be the same numbers, so you can just go ahead and cross those out. And then you have your 5 factorial, and so you would have, it would be much quicker to just enter this into a simple calculator. Expand that out as 5 times 4 times 3 times 2 times 1, and you're going to get 2,598,960. For all 5 cards to be the same color, you need to choose one of the 2 colors, either red or black, and then 5 of the 26 possible cards in that color. So the number of possible hands is 2 choose 1 times 26 choose 5. And so that's going to give us 2 factorial over 1 factorial times 1 factorial times 26 factorial over 21, because that's 26 minus 5 factorial, times 5 factorial. And so this is going to be 2 divided by, these are both going to be 1. So 2 divided by 1, so 2 times 26 times 25 times 24 times 23 times 22. Our 21 factorials cancel out. And then we'll have our 5 factorial, or 5 times 4 times 3 times 2 times 1 in the denominator. And we get 131,560. All right, so let's think about multiple events. When finding the number of ways both an event A and event B can occur, you need to multiply. when finding the number of ways event A or event B can occur, you need to add. So, William Shakespeare wrote 38 plays that can be divided into 3 genres. Of the 38 plays, 18 are comedies, 10 are histories, and 10 are tragedies. So our first task is to discover how many different sets of exactly 2 comedies and 1 tragedy can you read. And then we're going to find out how many different sets of at most 3 plays can you read. Okay, so for part A, you can choose 2 of the 18 comedies and 1 of the 10 tragedies. So the number of possible sets of plays is, okay, so here we've got our comedies. We're going to do 18, choose 2. And then the tragedies, there's 10 of them, and we're going to choose 1. So the number of combinations, 18 choose 2, is going to be 18 factorial over 16 factorial, because 18 minus 2 is 16, times 2 factorial. And then we're going to have, for our tragedies, 10 factorial, because there's 10 total tragedies. We're choosing 1, so 10 minus 1 is 9 factorial over 1 factorial. That's going to give us 153 times 10, which is 1,530. For part B, we can read 0, 1, or 3 plays. So since we've got different scenarios there, that we're going to, you either read 0 plays, or you read 1 play, or you read 2 plays, or you read 3 plays, okay? So we're going to do some adding for these. Because there are 38 plays that can be chosen, the number of possible sets of plays is 38 choose 0, plus 38 choose 1, plus 38 choose 2, plus 38 choose 3, and we use our formulas, and we're going to get 1 plus 38 plus 703 plus 8,436. And that gives you 9,178 different ways you can read at most 3 plays. Now, that was adding things up. Sometimes it's going to be easier to subtract. Counting problems that involve phrases like at least or at most are sometimes easier to solve by subtracting possibilities you do not want from the total number of possibilities. You're just going to have to think through a problem and decide whether you want to add up all the ones you want or figure out the total number available and subtract off the ones you don't want. During the school year, the girls' basketball team is scheduled to play 12 home games. You want to attend at least 3 of the games. How many different combinations of games can you attend? Now, one way to do this is to add up the number of combinations of what you want. So of the 12 games, you want to attend 3 games or 4 games or 5 games or 6 games or 7 games all the way up to 12 games. Okay, so the number of combinations of games you can attend is 12 choose 3 plus 12 choose 4 plus 12 choose 5 all the way up to 12 choose 12. And so that's going to be a lot of possibilities to consider, a lot of values to add together. So instead of adding these combinations, you can use the following reasoning. For each of the 12 games, you can choose to attend or not attend a game. So there are 2 to the 12th total combinations. Okay. If you attend at least 3 games, you do not attend only a total of 0, 1, or 2. Okay, so there's only 3 cases that you need to subtract off of the total number of possibilities. So the number of ways you can attend at least 3 games is 2 to the 12th minus the sum of 12 choose 0 plus 12 choose 1 plus 12 choose 2. 2 to the 12th is 4,096. Our individual combinations there are 1 plus 12 plus 66, just using the formulas that we've used before, and that gives you 4,017. So in this case, it saves some time. Now, with technology, sometimes it's easier just to go ahead and add all the combinations of what you want, especially if you have a hard time understanding the reasoning of how to get the total number that you attend. Okay, you have 12 games, you've got 2 choices for each game, either go or don't go, so it's 2 to the 12th. But for some people, that's harder than it would be just adding up the number of the different combinations to get what we want. All right, so now you need to do some guided practice. You're going to find the number of combinations, and then you're going to see, go back to Shakespeare's plays. And that's it. That's all the notes for today. Make sure you do that guided practice, and we will go over it in class. And I will see you soon. Have a great day.